Hi guys, welcome back. In the previous video we have completed the three topics: basic Linux commands and basic services to use in Kali Linux, and then service management. So if you guys missed that video, so please go and watch to get better understanding. Okay, so now we are going to see the command line fun. We will take an introductory look at a few popular Linux command line program in this video. Okay, first let's talk about the bash environments. Bash is a shell that allows us to run complex commands and perform different tasks from a terminal window. It incorporates useful features from both the Korn shell and C shell. Okay, environment variables. So when opening a terminal window, a new bash process which has its own environment variable is initiated variable, or a form of global storage for various settings inherited by any application that are run during the terminal sessions. One of the most commonly referenced environment variable is path, so which is a separated list of directory paths that bash will search through whenever a command is run. Without a full path, we can view the contents of a given environment variable with the echo command followed by the $sign character. Let's see some other useful environment variables include user and then pwd and then echo home, so which holds the value of the current terminal user's username, presence, working directory and then home directory respectively. We can define an environment variable with the export command. Let's see now. So I'm going to check the IP address of my Ubuntu machines in my network. So what is the IP address? Okay, so 176. Okay, so now for example we can now scanning a target and don't want to type in the system IP address repeatedly, so we can quickly assign it an environment variable and use the the export command box command makes the variable accessible to any sub process we might spawn from our current bash instance. Okay, so we can type this ping -c. If you set a environment variable without export, it will only be available in the current shell. So now you guys can see here. Okay, let's launch the another instance. So if we set an environment variable without export, it will only be available in the current shell. So now let's see the example, another example of bash, and try to display the variable again. So since we define our variable without the export command, we cannot access it in the new bash instance. After existing back to our original bash sessions, we have access to variable again. Okay, let's see what happens when we launch a new bash instance. Okay, global. So now we can check using the echo command. So this time we can access the variable from the new example. Okay, there are many others environment variables defined by default in Kali Linux, so we can view this by running the command env at the command line. Okay, so now sometimes it takes time to review an experiment with a predefined environment variable. Okay, so now let's see the tab completion. So the bash shell Autocomplete functions allows us to complete the file names and directory path with the tab key. So this is such a time saver that makes other shells which lack this feature feel clumsy and slow. Okay, so let's take a look at home. So let's take a look at how this works from the Kali user home. So list D and then press tab button, so you will get options. Okay, so the bash suggests that there are 3 directories starting with the letter. Then present our partially completed command for us. Since we decide to specific desktop, we will type followed by the tab key again. So at the point the bash shell magically auto completes. Okay, so it's really is a time saver, so when you use this tab key. Okay, so bash history tricks. When engaged in a penetration test, it is important to keep a record of commands that have been entered into the shell. Fortunately, bash maintains a record of commands that have been entered which can be displayed with the history command. Bash history tricks. So when engaged in a penetration test, it is important to keep a record of commands that have been entered into shell. Fortunately, bash maintains a record of commands that have been entered which can be displayed with the history command. So rather than retyping a long command from our history, so we can make use of history explains facilities. You can see here, for example, this command, each entry in our history is preceded by a line number. To rerun a command, we can simply type an exclamations. Let me show you that, and the number, if you type that, be followed by the line number. So the tail -entry, this is another helpful history shortcuts, the command. So by default, the command history is saved to the bash history file in the user's home directory. So 2 environment variables control the history size and the his size and history file size. His size controls the number of commands stored in memory for the current session, and then his file size can configure how many commands are kept in the history files. Let's check this now. Okay, so this variable can be edited according to our needs and saved to bash configure file .bash rcs that we'll explore later. We will explore this. So one of the simplest way to explore the bash history is right from the command line prompt. So we can browse the history with some useful keyword shortcuts, with the 2 most common being the up arrow and down arrow. So the up arrow scrolls backwards in history, and the down arrows scrolls forward. So last but not least, holding down controls and pressing or buttons will invoke that reverse I search facility. Okay, piping and redirections. Every program runs from the command lines has 3 data streams connected to it. That server as a communication channel with the external environment. The streams are defined as standard input, which is data fed into the program, standard output, which is output from the program, and default to the terminal, and standard error, so which contains error message and are also displayed by default in the terminal. So piping using the pipe operators, and redirection using the left and right angle bracket operators, also known as chevrons, or greater than and less than signs, connect the stream between programs and file to accommodate to near infinity numbers of possible use cases. So now redirecting to a new file. Okay, so in the previous command examples, the output was printed to the screen. This is convenient most of the time, but we can use the right angle bracket operators to save the output to file to keep it for future reference or manipulations. Okay, so let's see an example now. So let's okay. Okay, that's correct. So let's now enter. We can check now using the cat command. So if the words are there, okay, yes, it's saved already. So be very careful with the redirections. There is no undo function. Okay, so now we can see redirecting to an existing file. To append additional data to an existing file as opposed to overwriting the file, use the double right angle bracket operator. Okay, and then okay, so the double operator, and then yes. So once again, be sure, extra cautions with the redirection so you don't overwrite anything important. So now let's see redirecting from your file. As you may have guessed, we can use the left angle bracket operators to send data the other way. In these examples, we will redirect the WC command's standard input, which data originating from the file we generated in the previous sections. So let's try this with WC-M. So which counts characters in the file. Note that these effectively connected to the content of our file, to the standard input of the WC-M command. Okay, so this is a one, you can see here. Okay, so now we can see that redirecting standard error. According to the POSIX specifications, the file descriptors for standard input and standard output and standard error are defined as 0, 1 and 2 respectively. So these numbers are important as they can be used to manipulate the corresponding data streams from the command line while executing or join different commands together. So to get a better grasp of how the file descriptors numbers works, considers this example which redirect the standard error. So let's try now. So note this text dot, okay, no such a file or directory. So we can now you can see here the standard error. So now I have added this some words in the error.text. So now we can see the piping. So continuing with the example using the WC command, let's have a look at how to redirecting the output from one command into the input of another. So we will use the pipe characters to redirect the output of the cat command to the input of WC command. So this concept may seem trivial, but piping together different command is a powerful way to manipulate all sort of data. Okay, can see here. So count.text. So now we can check. Okay. Now let's see the text searching and manipulation. In these sections we will gain efficiency with file and text handling by introducing a few commands: grep, set, sed set, cut and awk. Advanced usage of some of these tools requires a good understanding of how regular expressions work. First, let's see grep. In nutshell, grep searches text file for the occurrences of a given regular expressions and outputs any line contain matches to a standard output, which is usually the terminal screen. Consider the example. So let's try this. So we listed all the files in the user bin directories with ls and pipe the output into the grep command, so which search for any lines containing the string zip. Some of the most commonly used switches included -r, and then -r is for recursive search, and -i to ignore the case of the text. Refer to the graph man page for more information. So now we can see set command. So set is a powerful stream editor. It is also very complex, so we will only briefly scratch the surface here. At a high level, set performs text editing on a stream of text editor, set of specific files or standard output. Let's look at an example here. Yeah, cool guy. So sed. Okay. So we created a stream of text using the echo command, and the pipe it to sed in order to replace the word cool with coolest. Note that by default the output of the entire command has been automatically redirect to the standard output or terminal screen. You guys can see here. I am a coolest guy, so it's replaced now. Okay. So now let's see a cut command. So the cut command is a simple but often comes in quite handy. Cut is used to extract sections of text from a line and output it to standard output. Some of the most commonly used switch includes -f for the field number we are cutting, and the -d to define the field delimiter. Okay, here we echoed a line of text and piped it to the cut command to extract the second field using a comma. As a field delimiter, the same command can be used to cut line found in the text file. So this time a list of users extracted from SD passwords by using colon the delimiters and retrieving the field first field. So now you guys can see here. So the web apps. So because this is the second. Okay. So now we're gonna see awk command. Awk is a programming language designed for text processing and is typically used as a data extractions and reporting tool. It is also extremely powerful and can be quite complex. So again, we will only scratch the surface here. So a commonly used switch with awk is -F, which is the field separator, and the print command. So which output the result text. Here we echoed a line it awk. Okay, let's try this. Okay, pipe, then awk. Okay, so now, okay, so here the dash capital F, which is the field separator, which is the field separators on the print command, which outputs the result text. Here we echoed a line and pipe it to awk to extract the first and third field using a double colons as a field separator. The most prominent difference between the cut and awk examples we used is the cut only accept a single character as a field delimiter, while awk is much more flexible. As a general rule of thumb, use a single awk command instead of multiple cut operation. Okay. Practical examples. Let's take a look at a practical example that ties together many of the commands we have explored so far. So I have grabbed the access underscore logs as Apache logs. Okay, so we can see how to use a bash command to inspect the file and discover various pieces of information. Example like the IP address, what exactly happened on the servers, so like this. So we can see the HTTP or GET request. So those kind of information we can see using the bash commands. So first we will use the head and WC command. So to take a quick peek at the log file in order to understand structures, we can just use the head command first. Okay. So before that, we can move the file first, so it's easy for us. Okay, now, so the head command display the first lines in your files. Okay, you guys can see here the IP address, GET, and then HTTP request, etc. So now we can see the WC commands along with the -L options displays a total number. Okay, we can now. So this is perfectly prep-friendly files. We will work well for all the tools we have covered so far. So we will now begin by searching through the HTTP requests made to the server for all the IP address recorded in this log. To do so, we will cap the log files and pipe the output into the cut and sort command. So this might give us a clue about the number of potential attackers we are dealing with. Okay. Here you guys can see the IP address. The IP address were recorded in the log files. Although it still doesn't tell us anything about the stuff like attackers. So next we will use iniq and sort to show iniq lines. Options of iniq will fix the output lines with the number of occurrence. A few IP addresses stand out, but we'll focus on the address that has highest access frequency. So first, to filter the suspicious IP address and display and count the resources that were being requested by the IP address. Okay, so you guys can see here. So let's say if you want to grab the IP address was accessing the admin directory exclusively. So let's inspect this further. Okay. So here you can see here with this command. So you have to use this admin to grab this all the result. So let's see now. So now you guys can see here all the IP address was accessing the admin directory. So let's now grab the get request. How to get the how to grab the get request. Okay. Cut fmd. Any queue. Okay. So now you can see the get only the specific IP address. So this is the basic example that helps you to understand how can you use the bash command, right? So editing files from the command line. So let's take a look at the file editing in a command shell environment. This is an extremely important Linux skills, especially if you happen to get access to a Unix like OS during a penetration test. Although there are text editor like gedit and mousepad, leafpad, the older versions of leafpad, and that might be more visual appealing due to their graphics user interface. So we will focus on text-based terminal editors, which emphasize both speed and versatility. Everyone seems to have a preference when it comes to text editor, but we will cover basic usage for two most common options, Nano and VI editor. Okay, so first let's see the Nano editor. So Nano is one of the simplest to use the text editor to open a file and begin editing. Simply run nano pausing a file. So name as optional argument. Once the file is open, we can immediately start making any required changes to the file, just as we would in graphical editor. The nano command menu is located at the bottom of the screen. Okay, some of the most common commands, most used commands to memorize include Control O, so Control K to cut the current text, current line, and Control U to uncut a line and paste it the cursor locations, and then Control W is used to search within the file, and then finally Control X is used to exit. Okay, for additional informations regarding Nano, please refer to the online documentation so you get more idea. Now we can see the VI editor. So VI is an extremely powerful text editor, so capable of blazing speed, especially when it comes to automatic respective tasks. However, it has extremely relatively steep learning curve and is now nowhere near as simple to use as nano due to its complexity. So we will only cover the very basics here. So as with the nano 2 editor, a file simply passes its name as argument to vi. So once the file is open, enable insert a text mode to begin typing. Okay, thanks to subscribe. Start. So to disable insert text modes and go back to the command mode, so press the escape key while in command mode. Use DD to delete the current line and press P to paste the clipboard contents. To delete the current characters under the cursor, press the X key. So, but there is a cheat code available on Google, so you guys can Google it to find a cheat sheet. So VA editor cheat sheet. So this is not a good website. So now comparing files. File comparisons may seem irrelevant. So comparing files. File comparisons may seem irrelevant, but system administrators, network engineers, penetration testers, IT support technicians, and many other technical oriented. Comparing files. File comparisons may seem irrelevant, but system administrators or network engineers, penetration testers, IT support technicians, and many other technical oriented professionals rely on these skills fairly often. In the sections we will take a look at a couple of tools that can help streamline the often tedious but rewarding process of file comparison. Okay, so now let's see. So the file is okay. You can see the scan A and scan B. We're going to use this for testing purpose now. Okay. So now the com command. So the com commands compares two text files, displays the line and or unique to each one as well as the line they have in common. So in the first example, you can display the unique lines in scan dash a dot. Okay. Com outputs three space offset column. The first contains the lines that are unique to the first files or argument. The second contains lines that are unique to the second file or arguments, and the third column contains lines that are shared by both files. So the IP is you can see here. So let's take a look at an example. So this time com displays only the line we found in both files. To add the 1, 2, column 1 and 2. So now you guys can see. Okay. So you can now see the diff. The diff command is used to detect difference between the files, similar to the com command. However, diff is much more complex and support many output formats. Two of the most popular formats include the context format and unified format. So we will see the diff now. So to display results in context formats, we need to use the to display results in context formats use the -C options. This output use this dash indicator to show that the line appears in the first files but not in the second conversely. So let's see what the unified format returns. So the most notable difference between this format is that the unified format doesn't show lines that match between file, making the result shorter. The indicators, however, have identical meaning in both formats. So now let's see Vim diff. Vim diff opens Vim, an extended version of VI with multiple files, one in each window. So the difference between the files are highlighted, which makes it easier to visually inspect them. There are few shortcuts that might be useful. For example, pressing Ctrl W followed by arrow key allow us to switch between windows. Pressing the right bracket. Okay, so pressing the right bracket and then letter C will jump to the next. Changing the difference on the left bracket followed by the letter C will jump to the previous change. The two key combinations, we will get a change from the other window and put it in the current one. Okay, so you guys can also Google it, the cheat code for cheat sheet for Vim diff. So it's easier for you to understand. Managing processes. The Linux kernel manages multitasking through the use of processes. The kernel maintains information about each process to help keep things organized. And each process is assigned a number called a process ID. The Linux shell also introduced the concept of jobs to ease our workflow during your terminal sessions. For example, this is a pipeline to process, so which the shell consider a single job. So job controls refers to the ability to selectively suspend the executions of job and resume their executions at a later time. So we can achieve this with the help of specific commands, which we will soon explore. Okay. Now we will see background processes. So the previous jobs in the module have been run in the background. So which means the terminal is occupied and no other commands can be executed until the current one finishes. Since most of our examples have been short and sweet, so this hasn't caused us a problem. We will, however, be running longer and more complex commands in later on chapters and modules. So which we send to the background in order to regain control of the terminal and execute additional commands. So the quickest way to background a process is to append an ampersand to the end of the command to send it to the background immediately after it stops. Let's try a brief example. We will send 400 ICMP echo request to the local interface with the ping command and write the result to the file. So the execution automatically run in the background. Okay, so one more much. So let's try a brief example. We will send 400 ICMP echo request to the local interface with the ping command and write the result to the file. So the executions automatically run in the background, leaving the shell free for additional operations. But what would have happened if we had forgotten to append the ampersand at the end of the command? So let's try remove that. Okay, so if we remove the ampersand, the command will run in the foreground. So we are focused to either cancel the command with Control C or wait until a command finishes to regain control of the terminal. The other option is to suspend the job using the Control Z after it is already started once a job has been suspended. So we can resume it in the background using the PG command. So you guys can see here. So the PG command, so the job is now running in the background, and we can continue using the terminal as wish while doing the keep in mind that some process are time sensitive and may give incorrect results if left suspended for too long. For instance, process control and kill. One of the most useful command for monitoring process on almost any Unix-like operating system is PS, which is shorter for process status. Unlike the job command, PS lists process system point not only for the current permanent sessions. PS is considered a standard on Unix like OS, and its name is so well recognized that even on Windows PowerShell. PS is predefined command, alias for the get process command, let which essentially serve the same purpose. As a penetration tester, one of the first things to check after obtaining the remote access to a system is the software currently running on the compromised machines. This could provide clues to help elevate our privilege or collect additional information in order to acquire further access into the network. So as an example, let's start the mouse editor. So it's a text editor, the latest version of Kali. So it's open now. So let's try find the mousepad process ID from the command line using the PS command. Will run PS with a dash EF. Okay, you guys can see. So that it's running now. Right. So when you run the PS dash -EF, so where the E select all process and F display a full format listing find our mousepad applications. That massive list is definitely not easy, but since we know the application name we are looking for, we can replace the options. So we can now replace the E with a dash capital C and specify the command name, which is mousepad in our case. So the process search has written a single result which contain mousepad process ID. Take some time to explore the PS manual, as it's really a Swiss Army knife of process management. Okay. So let's say we now want to stop the services. We can use the kill command. So the kill command can help us here, as its purpose is to send a specific signal to a process. The kill commands require the PID of the process we want to send the signal to. Since we have already gathered leaf pads, so the kill command can help us here, as its purpose is to send a specific signal to a process. The kill command requires the PID of the process we want to send the signal to. Since we have already gathered mousepad process ID, we can proceed because the default signal for kill is a sig term or request terminations. Our application has been terminated. So we can verify this with the PS after killing the mousepad. Okay, so let's verify this. See the process is not running anymore. Next, we are going to see file and command monitoring. It is extremely valuable to know how to monitor files and commands in real time during the course of the penetration test. To commands that help with the task include tail and watch. Okay, so tail, the most common use of tail is to monitor log file entire uh, file entries as they are being written. For example, we may want to monitor the Apache logs. A web server is being conducted by a given client. We are attempting to attack with a client-side exploit. So the -f option is very useful. So it is continuously update the output as the target file grows. Since our local Apache web server is already running, we will visit the default page using the Firefox. I will show you that. Okay, so now it's asking password. So let me open the another terminal so it's easy for you, the vertical terminal. So now we will visit the default page using Firefox. So it will redirect to the Firefox now. Okay. So if we go back to our terminal, we should see the request made in the log. Now the downloading files we will see now. So let's take a look at some tools that can download files to Linux systems from the command line. wget. So you guys might aware of this tool. So the wget command, which we use extensively, download files using the HTTP and FTP protocol. So wget has many features and can do for more than simply download files. So refer to documentations for more information. So the file, you can see here the file has downloaded successfully, right? Next we see the curl. So next we see the curl. So curl is a tool used to transfer data to or from a server using a host or protocol. A penetration testers can use curl to download or upload files and build complex requests. It is most basic use is very similar to wget, but with a lowercase o to specify the output file name. Curl is incredibly variable and you will find ample documentations and example usage. Okay, so just showing the examples. So yes, let's see now. Uh, Axel. Axel is a download accelerator that transfer a file from an FTP or HTTP server to multiple connections. This tool has a vast array of features, but the most common option is -n, which is used to specify the number of multiple connections to use, which also using the -a options for a more concise program progress indicators, and -o 20 and the -o to specify different file name of the. So as speeds up speed up download extremely well, and it's especially useful for large downloads. Customizing the bash environment. Customizing the bash environment. Bash history customizations. Earlier in the chapters, we discussed environment variables and the history command. So we can use a number of environments variable to change how the history command operators and returns data. The most common include hist control, hist ignore, and hist time formats. So the hist control variable defines whether or not to remove duplicate commands that begin with a space from the history of both. By default, the both are removed, but you may find it more useful to only emit duplicate commands. The hit ignore variable is particularly useful for filtering out basis commands that are run frequently, such as exit history, background examples, etc. So let's run a few commands to see that if history ignores our specific commands. So as expected, the ls and history commands don't appear in our command history. So lastly, his time format controls date and timestamps in the output of the history commands. So in the examples, we used percentage capital F or year, month, day, ISO 8601 format. So use the percentage F or year, month, date, or capital T, hours, time. Others formats can be found in the strf time language. We can use a manual page command, man command, to know more about it. String find. String time. Okay. So now we can see alias. An alias is a string we can define that replace a command name. Aliases are useful for replacing commonly used commands and switch with the shorter commands or alias that we define. In other words, an alias is command that we define ourselves built from other commands. For example, LSA. So we typically tend to use ls-la to display results in a long list, including hidden files. Let's take a look at how we can use an alias to replace this command. So by defining our own command lsa, we can quickly execute ls-la without having to type any argument at all. So we can see the list of defined alias by running alias without argument. Okay. Next is persistent bash customizations. The behavior of interactive shells in bash is determined by the system-wide bash RC file located in etc bash.bash RC. Okay, so the system-wide bash settings can be overridden by editing the .bash RC file located in any user's home directory. So in the previous sections, we explored the alias commands, which set an alias for the current terminal sessions. We can also insert the command into the bash files in user home directory to set up persistence alias. So let's see that some example. So list-etc list.bash RC. Okay, now we can check. Okay, so that's it guys, we have completed topics, the command line fund. So next topic we will see bash shell scripts. So please, okay, please subscribe my channel, press the bell button to get more update, share the video to your friends. Have a good day guys, bye bye. Please subscribe my channel, press the bell button to get more update, share the video to your friends. Have a good day guys, bye bye.